Hi kids, I know you remember the number line because I believe we may have talked about it at some point. If we haven't, oh well, here's two of them. It's called the coordinate plane. The first number line is the one that you remember that goes left and right into infinity. And the second one goes at a right angle to the first one and goes up and down to infinity. What's useful about having two of these and what's called the coordinate plane is that we can find where any point is anywhere on this chalkboard rather than just its left or right direction. So if I were to put a point right here, then I would say that point is 3 units along the first number line and 2 units up the second number line. So I would call this 3, 2 because there's a 3 on the first line and a 2 on the second line. If I were instead to plot a point right here, this would be -2 on the first line, +2 on the second line, so it would be -2, 2. But what if I instead wanted to plot a point like that of my own and say, I don't care where it is, I want to plot the point 3, 4. Okay. I'm going to move forward 3 units and up 1, 2, 3, 4 units. And I'm sorry, other ordered pair, but I need to draw a point right inside you because that's where 3, 4 should be located. This part should be fairly familiar, but the horizontal or left and right number line should always be the first number in the pair. The vertical or up and down number line should always be the second number in the pair. And the parentheses just note that it's a coordinate pair with a comma in between to show that you're looking for a point on this plane. And from there, you can actually measure the vertical and horizontal distance between 2 points that are measured if they have the same x coordinate, like, for example, this one. By the way, sorry if I hadn't gotten to this yet, but the horizontal number line is called the x-axis because x is the variable that we go to first. And the up and down number line is called the y-axis. And the second number here is, of course, called the y-coordinate. And I guess the first one is called the x-coordinate. So the name for the things in the parentheses in total is a coordinate pair because it's a pair of the x-coordinate followed by the y-coordinate. Because you do the left and right thing first and the up and down thing second. So, if the x-coordinate of 2 points are the same, like 3, 2 and 3, 4, then the distance between them is equal to the difference in their y-coordinates. I guess the absolute value of that, I don't know if you've learned that yet, but it basically means if it's negative, make it positive. So we would have 3, 4 minus 3, 2. Since our 3's are the same here, not just because there's a 3 here and a 3 there, but since they're both the same in the x-coordinate, we only need to worry about the y-coordinate, so 4 minus 2. And I will trust that you know enough math to say 4 minus 2 is 2, so the distance between these 2 points is 1, 2. These 2 points are 2 units apart. I'm going to go ahead and erase the equation right here so that it looks a little bit more manageable. And after that, we also have the distance between this point and that point, since these have the same y-coordinate. Those have the coordinates of 2 and 2 in the y-coordinate and 3 and -2 in the x-coordinate. So we're going to go ahead and take 3 minus -2, which I will trust you to count to 5. So 1, 2, 3, 4, 5. The distance here is 5. And whenever you're going to count the distance between this and this, you're going to have a slightly more complicated formula. If you're familiar with the Pythagorean Theorem, which actually, since this is a geometry class, I'm probably going to teach you in a little while. Just hold on to your hats for that one. I'll tell you the distance between that one and that one. Actually, I might as well just do it now. I can explain more in depth later, but the way you're going to do that is if you remember square numbers and square roots, we have the difference between 3, 4 and negative 2, 2 is you want to take this distance and that distance first. So we have vertical distance, so I'm going to call that V distance, equals, which is the difference in the y coordinate, is 2 because it's 4 minus 2. Horizontal distance, which of course I'm going to call h distance, equals 5. So total distance, which I'm just going to call distance, hold on to your hats, kids, is going to be 2 squared plus 5 squared, and then you got to take the square root of that whole thing. That's called the distance formula, where you take the square of the vertical distance and the square of the horizontal distance, add them up, and take the square root. So what this will actually be is the square root of 2 squared, which is 4, plus 5 squared, which is 25, equals the square root of 29. And that's going to be the total distance between this point and that point. Thank you for watching the video. I'll explain this more in depth with a principle called the Pythagorean Theorem later in the year.